All righty, here we are on to our next set. Let me go ahead and share my screen with you so that you can follow along. We are on the algebraic proofs set 2. Now, I'm going to skip this one. I would like you to do, actually, am I going to skip this one? No, I'm going to do it because this one's a little bit different than what you were doing before because we didn't actually fully solve this problem, did we? In the other ones, you ended up with just one variable and you solved for that variable. But here we have an x and a y, and in the end, we still have a y and an x. We've just put it in a different format. Okay, so we're going to do a few of these and figure out what we do. So what is our first step? Our first step is we've written out the problem. 6x minus 2y equals 14. This time you have to write that reason yourself. That is given to us. Now our second step, we have to think, what did they do between this and this? And to me, it looks like they subtracted the 6x on both sides to move it. So that means we used subtraction property. And then in this final step, we went from negative 2y equals negative 6x plus 14 to y equals 3x minus 7. So we have divided by negative 2 on both sides. So we used the division property. Right? Now this next one is going to be similar. We have an m, we have an a, we have a b, and we're trying to convert that into b equals something, okay? So we're still not just solving a direct equation, but we need to figure out logically what we did. So first, we write our problem, and we say that this is given to us. Now, second step, let's think about what they did. They have this half over here, and it is gone here. So they must have multiplied by 2 on each side. So we used the multiplication property. I'm going to start writing prop. This property takes a while. All right, next step, we have 2m equals a plus b. And then suddenly we have 2m minus a equals b. So we're going to subtract a from both sides. That's how we get that. So we used subtraction. So I'm going to write that as my reason, subtraction prop. And now we go from this 2m minus a equals b to b equals 2m minus a. Now that's one that's tricky. And so this is where I really recommend, you've got those notes at the front. This is one where it flipped sides just like this. Instead of a equals b, you can flip them around and say b equals a. That is the symmetric property. And so that's what we're going to write here. So make sure that you remember that those notes are there. You've taken them. You should use them. You're going to use them a little bit more today. All right. And this is the example I really want to make sure I show you. Is f plus g equals k plus 7. And we have a comma there, says k equals f. Prove that g equals 7. So this is a little different because we have this comma here. We actually have 2 lines of things that are given to us. So we're going to write given 2 times. Okay. So now let's take a look at this. It says f plus g equals f plus 7. Now, how did we get that from here? And this might take you extra thoughts. Remember that I'm a geometry teacher who has been using this to teach geometry for a while. So like I remember it, but sometimes you're going to take a while to spot it. So let's take a look. What is different between this and this is this k. That's the only difference between this line. And what we have instead of k is we have an f. And we knew that k equals f, so what we did was we substituted, we used the substitution property to trade the k for an f. That's what happens there. All right, and now we get to G equals 7. The way we did that was we subtracted F on both sides, and so both of our F's went away. So that was subtraction property. Okay, I'm going to remind myself how many are in this packet to see if I want to do one more. Yeah, I'm going to do one more with you guys, and then I'm going to cut the video off. So let's do this one. It says, if P, given that P equals 3Q, we have another comma, P plus Q equals R, comma, and R equals 20, prove that Q equals 5. So it looks like we've got 3 givens here. We have the given as P equals 3Q. We have a given that P plus Q equals R. And we have a given that R equals 20. So let's think about how did they get this from all this stuff? Okay, so P plus Q equals 20. Looks like we have P plus Q equals something right here. Equals R. And R equals 20. So this is super, super similar to this, where we take out the middleman. If A equals B and B equals C, so we have 2 things equaling the same, then we can set them equal to each other. So we're going to use the transitive property here. Now, some of you may ask yourselves, why is she using transitive? I wanted to use substitution because what I was thinking was, well, if R equals 20, I can substitute this R for 20. And you know what? I would take that answer too. Okay? So if you think about it slightly differently, that's fine, but I want you to be able to use your words to tell me what you're thinking. All right, so next step. Now we suddenly have 3Q plus Q equals 20. What did we do here? Well, the difference between these 2 lines is that this P became a 3Q. It looks like we can do that because of this. So what we did was we substituted. So we came to the substitution property by saying, well, instead of P, I can write 3Q, which is perfect. Now this next one, we don't really have a good word for that we've used so far. So I'm going to give that to you now. 3Q plus Q, you can say one of 2 things. You can either call that combining like terms, or I don't mind if you just write the word simplify, okay? Because you have simplified that statement, 3Q plus Q is 4Q, or you have combined like terms, 3Q plus Q is 4Q. So it's your choice. I don't care which one you write. Down at this last step, we've divided by 4 on both sides, which means we used the division property. And so all of that work gets us to prove that Q equals 5, and that's exactly what we have down here. So I hope that helps you. I have put these together. You need to do number 5, and it looks like I lost my must-dos on these, but you need to do more than this. So I'm gonna grab those and change it right now while we're talking, because that feels like the right thing to do, and then you'll know exactly what you need. So must do this one. Oops, that's a Zoom link. I don't know what's happening here. Okay, copy that. Okay. You must do this one. Okay. You must do this one. And you must do this one. So those are 1, 2, 3, 4 that you must do. And then you have a few more optional ones. And then I will meet you back here for segment proofs. Okay, so good luck. Ask your teacher, ask your classroom supporter to check your answers. We are here to help you. Have a great day. Good luck.